What's going on, ladies and gentlemen? Thank you so much for tuning in. I'm about to take you on a real-life service call here on Long Island, New York. We're coming just for boiler maintenance, but I uncovered something much more serious. A slab leak, which is going to prevent me from letting the boiler stay on and heat this home because it's September 30th and winter's right around the corner. Let's go. All right, ladies and gentlemen, I am here on my next service call. Maintenance. We have a Burnham Alliance SL indirect fired water heater. This is the 50. Looks like March 2008. And we have the US boiler Burnham Series 2. I'm gonna guess this is a 206. A lot of dust. Yeah, I was right. 206, which is 164,000 BTUs of input, 136 output. This is a atmospheric natural draft venting, hydronic cast iron, low pressure boiler. We have these two green things. These are circulators, commonly misinterpreted as pumps. They don't pump, they circulate. Keep that in mind. So we have two zones. This is a space heating zone with this large 1.25 inch copper piping. This is the supply side, by the way, and it's always indicative of arrows on the circulator, but also these check valves that let water travel in one direction. So that goes that way, across, disappears, reappears here, and that's our return. And feeding the indirect is the other circulator with 1.25 inch piping across and down. I don't know why they did it that way, but you know what they say, every installation is like a painting, a blank canvas. And they really didn't, they didn't really care too much here with, in my opinion, of aesthetics, as long as it works. But a lot of the piping is not really supported. You know, this is supported on itself. We have a sprinkler head here. Must be a code requirement for the local jurisdiction. Piece of band iron there with stove bolt. Look, see, why couldn't they put this there? Right? No, they put it there. Like, come on. No thought. Thermostat wiring. Expansion tank for the space heating. And that's a small expansion tank for the domestic water supply. Now, the customer has a couple problems here. Number one, every couple of years, they have to replace the pressure reducing valve. We're losing pressure in this system, and they want maintenance. It's a little dirty here, and we're gonna clean this up, so stick around. All right, let's start in the boiler vestibule. I'm gonna turn power off. That should kill everything. The control board there. The boiler control is now blank. There are no more lights on my switching relay. Kind of weird that they did this here, because this boiler can also handle wiring for an indirect. So I don't know why they did that, but nonetheless. This is our gas control valve. This is an intermittent pilot one. So there's a spark that gets generated by this module feeding this ignition wire to the pilot burner. So every time there's a call for heat, the gas valve energizes. As long as the safety circuit is all closed, the gas valve energizes for pilot valve, sending pilot gas to the pilot tubing. It lights. Once it senses that, it allows for main ignition by opening the main valve on the gas valve. Right below this control board, this little brass thing with the little wire going to it, that's our high limit sensor. And down here, that's our flame rollout switch. This is a fusible link, which burns out at temperature. So if there's flame rolling out because of a carbonized situation or not drafting the way it should, and it's rolling out the flames, that'll burn out, killing power to the boiler, or killing power to the gas valve. Right over here, we have a low water cutoff. Looks like it's dead, but then again, the power's off. Let's turn that back on. And I have a green light there for a split second. Okay, good. We have automatic air valve, safety valve, 15. Ooh, oh, okay, 30 psi. I thought that said 50 for a second. 30 psi relief valve, which is standard for a residential low pressure hydronic boiler. Circulator 1, circulator 2, automatic vent damper, and spill switch in case the flue is blocked. And that's about it. So let's start breaking this thing down, take the burners out, clean everything up there. And I want to keep an eye on the pressure because the customer's also complaining there's a pressure issue in this home. So right now we're at like a little under 10. My boiler feed valve, which is right here, is off, and that's preventing fresh domestic water from reaching the pressure reducing valve and hence refilling the boiler. We may have to deal with a leak here as well, and there's a slab and there's part basement, so good luck. All right, there's a shipping screw still on the combustion plate. Got these stainless steel burners. And since it is kind of quite dirty in there, I'm going to use this wrench to remove the pilot tubing from the gas valve. That'll make it easy. All that to remove the pilot burner because I want to clean the actual spark igniter with a soft wire brush before reinstalling it. Now, take a look inside of our combustion chamber. What's going on with this stuff? Looks like there's like some kind of nest was in here. What is up with that? See that? Insane. What the hell? Weird. Let's take a quick peek at the underneath of the cast iron. Make sure nothing out of the ordinary is there. Here we go. Just a little bit of white, I guess, soot around some of the tips, the pins on the cast iron sections, but other than that, no evidence of carbonization, no soot. So We're going to vacuum out the combustion chamber. I'm going to clean and then lubricate all the stainless steel burners with the WD-40 and a wire brush and a oiled cloth, and clean the pilot burner assembly. I'm now taking a soft bristled brush on my burners. If they looked caked up, I would use a soft wire brush, but they overall look pretty good. We're going to brush all these down, and then we're going to lubricate them with WD-40 and wipe them down. Beautiful. Now, as you guys know, I love WD-40, so we're just going to liberally spray everything down in here. Don't worry about it exploding. It's not going to explode. I'm going to wipe everything down. Okay. And this is also a good opportunity to get your rag even more oiled, which will be good when you wipe down all the burners. But look at that. Doesn't look like $1 million already? Okay. And I used that wire brush and carefully cleaned that spark rod right there. Beautiful. Now, one of the biggest gripes I have with Burnham and the US boiler is that they make it so difficult, or it's not easy to get the burner tubes in. You know, Well McLean and others just put the front part of the tube in first, and then you find the notch in the back where it goes into. No, not US boiler. Nonetheless, we're getting them all back in. Come on, baby. Oh, do you guys not know what I'm talking about? Let me show you. Come on. Get in there. Beautiful. I think she looks night and day difference. Let's get a picture of that for the service ticket and the customer's record. You can imagine why I'm doing this. So we have nice clean threads on this expansion tank for the hydronic water. I needed to take out the expansion tank to get to the pressure reducing valve. You can understand what I went through if you're a professional, and why I used a press coupling there instead of a sweat coupling, because I had to sweat the 1/2-inch copper tubing into that sweat adapter. In order to get in there, I needed to remove the expansion tank. And now she's reinstalled. And now we can fill it back up. Okay. Set to 12 psi. All right, let's open up the zone for the indirect. And let's fire up. We're good. Turn on the power to the boiler. Aquastat is set for, looks like 130. We're gonna crank that up. And that'll tell the boiler to turn on. That's the goal, at least. Okay. So the relay got a signal from the aquastat because the aquastat now has a closed circuit because it's a make on temperature rise and breaks at that set point. I probably said that wrong, but the aquastat will open the circuit when it's reached temperature. Because it's a switch, it closed 2 dry contacts on the zone R and W on the switching relay, which then powered the circulator with 110 volts, also closing the end switch to TT at the boiler to allow for boiler operation. The boiler now is running, right, with STA8 as the running code because the automatic vent damper switch, safety switch, was closed. The spill switch safety switch is closed. The low water cutoff closed. Rollout switch is closed. And the high limit is not at temperature. Make sense? Perfect. We're at temperature. I'm not going to confuse you by showing you what I'm doing, but we're purging the zone real quick. We're forcing water through the zone to the return to get all the air out that entered the system when we changed that pressure reducing valve. All right, so now it looks like we're good. Let's close that valve. Looks like she's struggling. Hope the water was on. Beautiful. All right, let's do a little bit more right there. Just a little extra on it, you know what I mean? Get that air. There's a lot of air there. I wasn't going to show you what I'm doing, but air will prevent circulation because these aren't pumps, they're circulators. Remember that, folks. They make great circulators, by the way. All right, I believe we're good. Let's close, open. And now we'll have circulation. Ow, damn, that's hot. All right, while we're waiting for the boiler to fire back up, we're gonna drill a hole in the flue piping, approximately 6 inches off the top of the boiler. All right, and once we fire it up, and we've been running for 5 minutes or so, we're gonna check our combustion gases. All right, we're gonna test for natural gas. Let's get the probe in there. We wanna put it about halfway into the flue. Let's let this sit in there for about 5 minutes and see what we're reading. All right, I like these numbers. 6.202, 36 ppm of carbon monoxide, gross efficiency of a hair under 84, and CO2 8.24%. So good numbers here, folks. The boiler's at temperature again. So we're going to wait to do our draft analysis, make sure we have good positive, negative draft going up, but we should be good. All right. You can scan that QR code. Brings you right to our booking page on our website to book an appointment right online. There's a combustion and draft test. We're good. We get rid of my hose. And now we need to have a conversation with the homeowner about where pressure is going when you open up that valve and that valve. That line goes into a slab. The whole front of the house is a slab and there's a leak there. So you may be wondering, what are we going to do about the leak and the pressure loss of the hydronic heating system? I prepared and forwarded a proposal to perform a comprehensive slab leak detection service utilizing equipment that we acquired and then subsequently trained with for Leaktronics. They make precision audio leak detection equipment and video as well. It's great stuff. We've done several slab leaks with their equipment, and literally it allows you to have x-ray vision, and X marks the spot. It's a lot of training involved. It's not so easy, but I think me and Stoli can handle it. Ain't that right, Stoli? Stoli! What do you think? Maybe? Yeah? We got this. Catch you in the next one. Be well, God bless, stay safe.